proofs on your homework, and there will be proofs on your test on this chapter. First thing I want you to do is make sure that you are on section 4.5 and that you're at example number 4, because that's where we're starting today. So find example 4 on 4.5. It's probably on the back or near the back. Is it on the very back? Okay, it's on the very back of 4.5. So very back. And then there's one typo going back to chapter 1 and correct notation. This should say line segment BC is parallel to line segment AD. So make sure you put little segments over that. You just want to constantly use good notation. Okay, when you go to approach your proofs, the first thing you're going to want to do is write down your given. But I'm going to advise you to write down part of your given and ask yourself, what does that tell me that I could now mark congruent in my picture? Then go to the next given. Write it down. Sometimes it's just going to tell you exactly what is congruent, and you'll just mark it congruent. Sometimes it's going to tell you some information like BC parallel to AD, which isn't about two things being congruent, but will help us figure out something that's congruent. So I will advise you, and that's how I'm going to work every proof today, is don't write all your given at once. Write down each one separately and see what does that now tell you. So we'll start with BC is parallel to AD. You need to draw the picture. So if part of your assignment's on a worksheet today and part of it's out of the book, if it's in the book, draw the picture on your paper. Go to your picture and mark it. So they're telling me that BC is parallel to AD. Again, arrows mean parallel, not congruent. Then you're going to think back to chapter 3 when we had parallel lines cut by a transversal, right? So BD is now a transversal, and we're looking at the top and bottom, and they are given to be parallel. What should be congruent in that picture based off what we learned in chapter 3? Our alternate interior angles. Now the next part's the hardest part. Can you name the correct angles that are alternate interior and name them how they would match up? So first of all, what's one of our alternate interior angles formed by the two parallel lines? ADB. So angle ADB. So I'm going to write that down first. Angle ADB is going to be congruent to the other alternate interior angle. What is the other alternate interior angle? Good. So we started at A, and that was the side that had the parallel mark on it. So you want to make sure when you name the other angle that you start with that same line. So CBD. So angle CBD. Okay, I forgot to write down my reason for number 1. What is my reason for number 1? Given. And now what is my reason for number 2? Not definition. Okay, be careful, Barrett. Converses prove lines what? Parallel. Are we saying that two lines are parallel here? No. The converse is only used if your statement is about lines being parallel. So they gave us the lines were parallel. We're concluding the angles are congruent. So what's the theorem? Exactly whatever kind of angles they are. Alternate interior angles theorem. Now be super careful. Were the other lines, BA and DC, were those marked parallel? No, so I have a lot of students who usually want to make the mistake of saying, well, this angle right here is congruent to this angle right here by alternate interior angle theorem. But those angles are made by this line and this transversal. Are those two lines on the left and right parallel? We don't know they are. Nothing told us that they were, right? So we can't say that the green angles are congruent because we don't have the lines parallel. Only if the lines are parallel will the angles be congruent. So just be really careful that you don't list those angles. Okay, so right now we have one thing marked congruent. How many do we need for our shortcuts? 3. And let's review the 5 shortcuts real quick. So give me one of our shortcuts. SAS. Another one? SSS. Say it again. AAS, another one, HL, and the last one, ASA. What are the two that never work? ASS, which is our bad word, doesn't work. And if you spell it backwards, it doesn't work. So those don't work. And what's the other one? AAA. Those are never options to prove triangles congruent. Those should never be listed in a proof. They should not have been listed on the worksheets that you gave me. Those don't work, okay? So make sure if you did make a mistake and list those on the worksheets that you're getting that in your head now. Those never work. Okay, so we only have one angle marked congruent so far. Go back to your given. We've already used this part. Now we're going to write down the next part. Number 3, BC is congruent to AD. Given. So write the given, decide what you can conclude. Write the given, decide what you can conclude. Go to your picture and mark it every time. So BC is congruent to AD. And they already had that marked in the picture, but just making sure we have it marked. So how many things are marked now? 2. And we have 2 things listed congruent in our proof. So how many do we need? 3 total, so we need 1 more, right? Do you see something we could mark congruent and back up with a theorem, postulate, or property? Sydney, what do you see? Yes, very good. So we can mark this side, BD, is congruent to itself. What property tells me that? Reflexive property. And so you probably used that quite a bit on those worksheets. There was reflexive property all over the place on those worksheets. So we need to write that down now, excuse me, in our proof. But be careful when you write this one. Does angle B land on top of angle B in the next triangle? No. Very good, Jacob. BD is congruent to DB. The reason we're switching it is because we'll have to flip the triangle over before they match up. Or another thing is angle B matches up with angle D. Or you can kind of cheat a little bit. If you look at the proof, what it tells you to prove, it shows you how it's supposed to be. BD should be congruent to DB. So if you're ever unsure, look at what the congruent statement is and see how should it go. Okay? And again, that was the reflexive property of congruence, right? And now, do we have 3 things marked in our picture? And so now you have to decide which of the 5 ways have we proven the triangle's congruent. So based on the markings in the picture, which of our 5 ways do we have? Good, SAS. We have a side, and where the 2 sides come together, that point is the angle that we have marked. Same in the other triangle. Side, side, and where those 2 sides meet is the angle that's marked congruent. So we have side, angle, side. So your last statement in your proof, remember, is always what they tell you to prove. Triangle ABD is congruent to triangle CDB. And the reason was side, angle, side. So what I hope you see is this really isn't much different than what you just did on the worksheets. We're just putting it in a 2-column proof. Would you agree? Okay. Maybe a little bit harder just because you have to name things correctly, but pretty much the same idea. Okay, let's try the next one on 4-5, and then we're going to move back to 4-6. The more of these we can do together, the better you're going to feel about it when you're doing it on your own. So again, what's the first thing we're going to do when we start a proof? Okay, start with your first given, and I'm telling you, I feel like it'll help you so much if you'll just write part of it and ask yourself, what do you know from that? So QP bisects angle RQS given. Okay, so they're saying ray QP is bisecting what? Angle RQS, right? What does it mean to bisect? What's it mean to bisect something? Okay, you split it down the middle. What's a better way to say that? Okay, it splits it into 2, and I'm going to use the word congruent parts, okay? It does pass through the midpoint if it's a line segment. But in this case, we're bisecting an angle, so an angle doesn't really have a midpoint. So if I take an angle and I split it into two congruent parts, what shapes am I splitting it into? Not triangles. If all I have is an angle, what shapes do I get when I split it into two congruent parts? Two angles, right? What I see the biggest mistake with is students try to tell me next that there are some segments congruent. You're not bisecting a segment, you're bisecting an angle. You should get two congruent angles, okay? So we're looking at what angle again? RQS. So now what are the two angles that QP splits that angle into? SQP and RQP. So this angle and this angle. Do you guys see that? If you take an angle and you bisect it, you should get two congruent angles. So this ray is splitting this angle into two congruent parts. So we're going to write that down now in our proof. And Jackson did a great job naming that. Angle RQP is now congruent to angle. And since we started at R, where do we have to start on the next angle? S. SQP, because we want the parts to match up all the way through. And what's the reason? How did we know that? Exactly. What did they tell us up here, number one, that we used to make that decision? They gave us the word bisects. That word is what made us know that it was split into two congruent parts. So it is the definition. And I would accept definition of bisects, but the better answer is definition of angle bisector because it's bisecting an angle. Okay, so definition of angle bisector splits the angle into two congruent parts. Okay, now we move back to the given. Don't forget we didn't write all the given down. So number 3, QR is congruent to QS. Given. Don't forget to mark your picture. QR is congruent to QS. So once again, we have a side, we have an angle, we have two things, we need a third thing. Do you see something in those two triangles that we can mark congruent and back up with the reason? Good, reflexive property. What piece is reflexive in the two triangles, Dylan? QP. So this side right here, QP, should be congruent to itself. So number 4, QP is congruent to QP. And this time we're not going to flip it, right? Because angle Q does land right on top of angle Q when they fold and match up. And Dylan said that was reflexive property. Don't forget to put of. What is it of? Congruence, because that's the symbol that you have in your statement. Okay, so now do we have 3 things in our triangles? Which of our 5 ways do we have in the picture? Okay, I heard 2 people say it. SAS. Again, look at your picture. You got a side and a side. Is it the angle made by those 2 sides? Yes, so that is the included angle, which is side, angle, side. So number 5 is SAS. And the statement is what they told us to prove. Triangle RQP is congruent to triangle SQP. Is this making sense? Yes, sir. Mm-hmm. Mm-hmm. Yes, you pick one of the 5 ways that you have marked in your picture. Okay, these are the only ways that you're going to be able to prove those 2 triangles congruent is one of our 5 shortcuts. Okay. All right, look at your 4-6 notes, and I'm going to see about doing at least one of the proofs on there real quick, and then we're going to look at the new lesson. Actually, I don't think I am. I think we'll skip the ones on 4-6 because they're similar to these right here, and let's go ahead and go on to 4-7, and we'll practice some in 4-7, okay? So go to your 4-7 notes. Before we look at 4-7, I'm going to play the little video again. Did I play that for you guys last time? Okay. So whether you want to hear it again or not, I'm still going to do it. Because, not to torture you, but in the video, the little music song, they talk about this lesson at the very end. So I want you to catch it again. And it's going to help you one more time kind of remember these 5 shortcuts. So I'm going to pause the video here for a second.